In this lecture, we shall learn about logic gates, which are the building block of any electronic circuit. Opening a real gate allows people to pass into the property. Similarly, the logic gate allows the electric current to pass if it is open and does not allow the electric current to pass if it is closed. The logic gate has two states, open or close, true or false, 1 or 0. All arithmetic operations and logical operations that you execute on a computer are finally represented using logic gates. There are different types of logic gates. The most basic ones are OR gate, AND gate, and NOT gate. Let us first look at OR gate. The symbol for OR gate looks like this. It takes two input, say A and B, and generates one output, say Y. All logic gates take some input and generate the output. The input may be in terms of high voltage 5 volts or low voltage 0 volts. 5 voltage may be considered as 1 or true and 0 voltage may be considered as 0 or false. The output determines whether to open or close the gate. If it is true, then open the gate, else close it. In the case of OR gate, output is true if any one of the input is true, else the output is false. Let us assume true is represented by the bit 1 and false by the bit 0. As the OR gate has two inputs, there are 2 to the power 2, that is 4 possibilities, which are represented here in the truth table. If A is 0, false, and B is 0, then the output is 0, false. That is, the gate is not open for passing the electric current further. In all other cases, the output is true. That is, the gate is kept open for passing the electric current further. Let us consider an example of a home fire alarm system. Say it takes two input. First one is true if temperature is greater than 100 degrees Celsius, and second one is true if smoke is detected in the house. The alarm will remain off if first and second input both are false. That is, temperature is less than 100 degrees Celsius and smoke is not detected. In all other cases, the alarm rings. This is an application of OR gate. Consider a login page of your popular social media website. It asks you to enter two inputs, username and password. It allows you inside only if both username and password are correct. This login scenario can be represented using AND gate. This is AND gate and its symbol looks like this, with two inputs, say A and B, and one output Y. The truth table for AND gate is shown here. The output is true if both the inputs are true. In all other cases, it is false. In the login scenario, input A is the username and input B is the password. Access is granted if both the username and password is correct. In all other cases, the access is denied. This is an application of AND gate. Now we shall discuss the NOT gate. It is quite different as it takes only one input, say A, and generates one output, say Y, as shown here. It is also known as an inverter as its job is to invert the input, meaning if the input is 0, output will be 1, and if the input is 1, output will be 0. This is an inverter. It always outputs the complement of the input. Complement of 0 is 1 and complement of 1 is 0. Before we end this section, let us now see how binary addition of single bit is performed. First, let us understand how decimal addition is done. 2 plus 3 is equals to 5. Here the sum is 5 and carry is nothing. Similarly, 4 plus 9 is equals to 13. Here the sum is 3 and the carry equals 1. So the answer is 13. Now let's get into binary addition. First, 0 plus 0 is sum 0 and there is no carry. Second, 0 plus 1 is sum 1 and no carry. Third, 1 plus 0 is sum 1 and no carry. And the fourth one, 1 plus 1 is sum 0 and carry as 1. Let us understand the last one in more details. Binary 1 plus 1 is sum 0 and carry 1. How? Let us perform decimal addition on the same. Binary 1 in decimal is also 1. Decimal 1 plus decimal 1 is decimal 2. Now let us convert decimal 2 into binary. We get the answer as binary 1 0, which is available here as sum 0 and carry 1. That's all. I hope you get it. That's all for this video. We are going to use some concepts from this lecture in our next lecture. So until then, stay tuned.